Even on a still day, a field of crops is in constant motion. In an invisible process, plants pull moisture from the soil and release it into the atmosphere as vapor. Engineers and agronomists call this combined water loss evapotranspiration. It represents the total amount of water a crop actually consumes during its growth cycle. Before the development of modern digital sensors, calculating this volume was a primary engineering challenge. Without a precise way to measure this loss, farmers risked either underwatering their crops or wasting water through over-irrigation. The Blaney Criddle method was developed to address this problem, becoming one of the most established techniques for quantifying crop water use. The method allows agricultural engineers to estimate a crop's water requirements using basic, accessible environmental data. Quantifying this water loss was the first step toward moving away from guesswork and establishing technical control over agricultural water supplies. The core of the method is the master equation used to find the monthly consumptive use, or C sub U. C sub U is equal to the crop factor, K, multiplied by the sum of the monthly consumptive use factor, F. The first variable, K, is the crop factor. This factor accounts for the biological differences between plants. Summer corn consumes water at a different rate than a field of winter wheat, and the K variable adjusts the math to reflect those specific requirements. While the crop factor K identifies what is being grown, calculating the final water requirement depends on the regional environmental data found in the variable F. This variable F is the monthly consumptive use factor. To find F, engineers use this secondary equation, P divided by 40 multiplied by 1.8T plus 32. Here, T represents the mean monthly temperature, measured in Celsius. The variable P represents the percentage of annual daytime hours occurring during that month. Instead of measuring sunlight daily, engineers traditionally look up this value in standardized sunshine tables, which provide the daylight percentage based on the latitude of the field. By combining local temperature with historical sunlight data, the frugal formula produces a numerical value for the environmental demand placed on the crop. Knowing how much water a plant consumes is only the first part of the calculation. For an engineer, the goal is to determine how much water must be manually added to the field. This final value is the consumptive irrigation requirement, or CIR. The logic of the CIR equation is a simple subtraction. Take the total water the crop needs, C sub U, and subtract the total effective rainfall. This accounts for the water nature provides for free. What remains is the deficit. This CIR value tells the engineer exactly how much supplemental water must be delivered through pumps and irrigation systems to keep the crop healthy. The Blaney Criddle method provided a standardized mathematical framework for this process, allowing engineers to plan the infrastructure and water management strategies used to support agricultural regions.